So this session is going to move down to another piece of the hardware puzzle, which is the inverter. And we're calling this session Advancing the Inverter Value Proposition in what's turned out to be a very competitive landscape in the past couple of years. Actually, I was talking to these guys earlier. They're so moved by the fact that module prices haven't been coming down, so they're going to give everybody a free inverter out there. No, I'm just kidding. But I'll let everybody introduce themselves. But beyond just who you are, your company, I'd also like to answer a quick softball question, which is, do you believe inverters are a commodity product or not? So we'll start with you, Mike.
So, morning, thanks, MJ. My name is Mike Rogerson. I'm at SolarEdge. I head up the marketing for the North America group, which is based out of Silicon Valley, California. My background, I was at Applied, selling some of those factories, and I've been on the module side as well, so I've kind of seen both pieces of it, the commoditization of the module market, and now I'm also on the AC side with the inverters. SolarEdge is somewhat unique in the product that we sell. We have an optimized inverter solution, which takes a power optimizer on the rooftop. It's not a full microinverter, just does DC to DC. And then we have a fixed voltage inverter on the side of the house. So it's a unique product in a lot of ways. And I think to your second question, that's sort of the commoditization. On the first hand, I'd say no, obviously, but the economics are different. So in the modules, back when the pricing pressure started, they were 50% or more of the system cost. They were a big chunk if you're going to try and reduce cost of how you do it. And so we saw those prices come down. On comparison, if you look at an inverter, it's 10% of the system cost. If you look at what's happening in the market and the way things are playing out, we're seeing more diversification, more variety in inverter space. David, you guys have launched a product recently that kind of proves that out. SolarEdge has a unique product. We have everything from microinverters, optimized inverters, string inverters, central inverters, and it just keeps getting richer. I think the market is just finding ways to optimize the installation process, to lower labor. Going forward, I don't think it'll change. There are so many requirements coming down the line with Rule 21, with storage, and the inverter is going, today it's the brains of the PV array. I think it's developing its own nervous system. So it's going to be the entire nervous system of the PV in general. So in short, no?
Great. Michi, do you want to?
Yes, good morning, everyone. My name is Michi Zhang. I'm the CEO of Sungrow North American Operations. Sungrow is number 2 inverter manufacturer of the world. With last year, we shipped about 4 gigawatts on a global basis. So we entered into North American market about 3 years ago. We have Fremont in Toronto, Ontario, and also Fremont out of San Francisco Bay Area. So my background has always been PV inverter, and I've been working with Satcom, in the product launching and R&D department for lots of years. And in the past few years, we do see a consolidation of the inverter business, and a lot of changes and lots of new requirements from the customers. So I think there's, to answer your soft question regarding inverter is a commodity or not, I mean, there's 2 sides of that question, right? So pretty much we see that the market is shifting. The market is shifting. We have residential, we have commercial, and we have utility. I'm pretty sure that on every market sector, the requirement would be different. User-friendly, accessibility, and also OEM requirement, that's for the commercial side. For utility, it's got to be more on the grid supporting functions, the long-term assets management, and how you can really meet those requirements. So I would say, inverter, the pricing is really facing the pricing dropping in the next couple of years, and we will keep seeing that. But again, how to really be fast respond to the customer's requirement, to meet those requirements, that's going to be a question. And we saw all those competitors, and we see that technology will be more and more transparent. So there's no really rocking science behind it, we believe. It all becomes, the requirement will become more and more standardized, I would say. So as we move into different market sector, we see a standard requirement out of that standard market. Then we say, okay, we don't want to call that inverter as a commodity, but I would call that, it's called a smart commodity. With different market, we can see the different, very rigid requirement for that specific requirement.
Sure.
So,
great. David, anything to add?
Hello, everyone. Introduce myself, and I'll touch on that, myself, some background. I've got a background in high-volume automotive manufacturing, research and development in semiconductors, and for the last 12 or 13 years, product management for power electronics in the PV industry. And I think, I certainly agree with the two panelists in front of me. There's a significant content of commodity components in the recipe for an inverter. We can't deny this, right? It's a lot of copper, steel, PCB, et cetera. There are also a high percentage of application-specific technology, the switches and the high-efficiency magnetics. So, it's not a commodity experience. It is a lot of commodity product components go in, but it's just not a commodity experience. And I think, it's analogous to the automotive industry. You look out there today and you can call that a commodity product, but you still have premium brands. And oftentimes you have premium brands within the same brand. You have Acura and Integra, a Lexus, a Toyota, right, Affinity, Nissan, and they're commanding a higher premium, first cost. They're wrapped with better service and support. So I think, we're going to head that direction as we mature, and we see that happening today. I think that's my opening salvo.
Great. Mark?
Good morning, everyone. I'm Mark Goodrow. I'm with Selectria Renewables. Can you all hear me? And Selectria is a leader in North America in the inverter space, and we serve all markets, residential, utility, and commercial. Our company was actually acquired by Yaskawa Electric earlier this year. We had been a private company, and now we're part of a diversified global company, which was an important move for us as we go into the next stage of growth and expansion. And to answer the question on whether it's a commodity, I actually started in the solar business about 8 years ago. I worked for a company that provided turnkey module manufacturing equipment. So, one of the differences with modules is you could pretty easily get into the business, whereas when inverters, I don't think it's quite as easy, and that therefore not the proliferation of inverter companies right at the beginning when the industry boomed. But beyond that, these guys said it, I think, pretty well, that there's a real diversity of products in the inverter space. So a lot of different selection and a lot of meaningful differences. When it comes to some of the main features like efficiency and conversion, they're alike. But I do agree that brand is important, and in the company, and that a lot of people value experience, service and support, and the financial strength of the company to back that 20-year warranty. It's arguably the most critical component of a PV system. And for all those reasons, I think that brand is key.
Sure, and all of you guys touched base on some of the customer experience, so to speak, and the services that you're providing around just the hardware. So can you speak to me a little bit about what sort of services are being asked of you, beyond just delivering, making sure that inverter's at the job site at the right time? What else is being asked from the inverter manufacturers for the customers?
So I'll take a stab at it. We do a lot of consultancy. So our product is unique. It's different in a lot of cases from what they're used to. If they're used to doing a large central and commercial, or even a string inverter, three-phase for commercial, now we have optimizers in there. The string length is different. We're doing a string stretching technology that allows you to put 12,750 watts in a single string, and that's 2.3 times longer than what they're used to seeing. They want to know how to do that. How do they talk to the NECs? How do they get through the HJs? So that's essentially what we're focused around, is mainly the consultancy side to get them used to and comfortable with the new technology.
Great. Mark, you guys provide more your standard inverters, they don't have necessarily DC optimizer attached, or no microinverters. So what sort of services then, or added customer experience are you talking about?
We serve primarily the commercial small utility space. That's been the bulk of our growth the last few years. So we work a lot with customers, really, in addition to providing the inverter, helping them get interconnection approval, working through impact studies. When you're tying directly to the grid, there's a lot of that work that goes on, working with our power systems engineers, their engineers, and the utilities to make sure we're meeting, often special requirements.
Great. And then, David, you talked about brand, right? And you have different levels of product. And part of that brand, of course, is going to be looking at the quality of the brand, the reliability of that inverter. What are the right questions or the right metrics to be thinking about when we talk about inverter quality and reliability?
Okay, that's a really good question. I think I'll start off weeding some no's out. I think MTBF is important. It's valuable, but it doesn't do any analysis associated with the failure trends, right? It's a number associated. It's also applied to a very complex electromechanical system. So I think it's an important number. It's not the number people should be focusing on, right? So I'm going to weed that one out. The power ratio, this has been dealt with quite extensively in the last couple of years as people have looked to put more and more density of DC on the AC inverter. And despite all that research, it's still the rule of thumb is sticking there. It's somewhere between 125 and 135. So I mean, I think we're going to rule that one out as well. Then you start to look at uptime and availability, and I think these are oftentimes confused. I think, from my perspective, availability is the product of my uptime divided by my total, time. So I think really for me, if you want to look at the metric to use, it's availability.
Okay, availability being defined as
its availability is equal to your uptime divided by the total time, that is available. So if you're available to produce energy,
sure.
That's simple.
That's
right.
Yeah.
If the sun's shining and the grid's good and you're working, you're available.
Sure. And then, Miji, I want to ask you, when we're, if pretend like I'm an EPC, I'm evaluating your inverters with these other gentlemen, perhaps some other inverter manufacturers, thinking about this sort of reliability, these metrics, maybe uptime, availability, anything else that you might add to that, how can I just take a glance at these companies and figure out which one has the better metrics there? What sort of data is available? What sort of things would I be able to get access to?
Of course, yes. As a new player into this market, as as an EPC company evaluating different inverter manufacturer, the first question I would ask is, first of all, is this company going to be healthy or not? That's a long-term sustainability and all that. Then moving forward, I will look into the reliability of the product and also the product offering for your applications. I still remember 5 or 3 years ago, the power plant was designed around the inverter. Now this is the other way around. So pretty much you have to provide the product which suits customers' need. So understand the application and the detailed requirement, then propose the best product for them. For instance, for this year, we offer 4 different types of string inverter pushing to North American markets, from 30 kilowatts all the way to 60, right? So one of the value we provide to the customers, we did very thorough studies compared with using the central inverter versus your string inverter, and really compare the failure rate, compare with MTBF, compare with how you can get the best availability of that design to provide to the customer. So this is something that we think as a pure player, we can offer to the customers. It's not only the reliability number, and also in terms of how we can optimize your design to meet your availability requirement for the long run.
Sure, and I'm glad you brought up the trend or the products of three-phase string inverter. And as I mentioned in my presentation, certainly this trend towards decentralization, distributed optimization, whether it's on the DC-DC side or whether it's just building larger plants with smaller scale inverters, seems to be something that's taken off. And I'm wondering, as you guys are looking towards your product portfolio, next year and out in future years as well, I mean, do you continue to see that trend happening, and how is your product portfolio, will it react, or how might it react to that trend?
So I can kind of get on that. We just recently closed the megawatt project. We have up to 5 megawatts globally, and these are being done with three-phase string inverters. The 5 megawatt project was done with a 17 kilowatt AC inverter. So, I mean, you can imagine that's a big change from what you would have seen 3 or 4 years ago. But the economics and the risk mitigation is a big factor in the commercial side. So what we're seeing is people shifting their focus away from these central power plants to maybe more of a distributed architecture within the array as a way to mitigate risk. There's a lot of effort that goes into the upfront cost reduction, but then there's this big bucket for a commercial multi-million-dollar asset that is all about keeping the thing up and running, keeping availability high. And so we see that as a trend kind of going forward as a way to continue to output the energy and to keep it at a very steady, high output.
Where do you see that line, where it makes sense up to a certain megawatt threshold, and beyond that, it might not make sense?
So, I mean, we're pushing the line now. Right now, I'd say the frontier is probably 10 megawatts for us. We've done designs on 10 megawatt projects. And for people that want to look at more of a centralized structure, you can pour a concrete pad if you want. You can build a structure if you want. You can put a bunch of string inverters inside it if you want. if you want that experience of having a large centralized inverter, it can be replicated with a string inverter. There's no real difference there. If you want to distribute the inverters throughout the array or have them on a main access road, you can do that. So I think the options and the flexibility is open and available to you. Right now, what we push the frontier to is around 10 megawatts, but I don't know that that's really a hard line.
Sure.
I'd like an opportunity to comment on as well. As Ed mentioned, Keiko New Energy, it's a global company. We've got 20 megawatt single phase string inverters that have been running for 7-8 years. I mean, there's really been some interesting things done in Europe for the right or the wrong. Talk about a couple things here. In terms of the services and support, Keiko has enough products that we're able to disrupt our own business model. So we're offering the decentralized, 3-phase string inverters. At the same time, they're competing against our large megawatt central inverters. And we have to act as a consultant to the customer, sell a solution, and understand some of their unique needs associated with that. And if you look farther down the pipe of some of the power electronic technologies that are coming out there, there is a definite move between 50 and 100 kW on these 3-phase string inverters. Some real interesting price points that are coming out there, and the price points are phenomenal. And I think what you're going to see is that 10 megawatt number go up as you start to look at these 75 to 100 kW 3-phase string inverters that are starting to export AC at also very high values, right? No longer is it going to be your 370, it's going to be 480, it's going to be 690. So, we're preparing for this. And we also have to engage with the customer in a solution sales methodology to understand, look, what suits this application specifically. And you can't be afraid to disrupt your own business model, because if you don't, you're going to go out of business.
That's right.
And so Sungrow has I believe a 50 or 60 kW string inverter now.
That's right.
And in terms of, what, first of all, is going to enable that, maybe pushing towards more like the 7,500 kW string inverter, and what sort of economics does that then enable as well?
I think that's a very interesting point. First of all, Sungrow this year bring 56 and 60 kilowatts inverter into that market. Actually, we have the largest string inverter in this market, really pushing the edge of using decentralized concept. And one of the comment I would add is, we're always talking about the threshold of using string versus central. I guess this is really depends on your financial structure, your investment return mode, and also your application requirement, your location of the project. So I would say for each specific case it will be different. One value we can provide is we have a program that really evaluate and how to maximize your energy yield and minimize your downtime and for long-term O&M. We call that assets management program. Mm-hmm. So it's pretty much you're not only using inverter as a commodity, is using inverter as a way, as a tool to evaluate for the long-term O&M perspective, what will be the best inverters to suit the application. We believe there's no inverter that can fit all. It's always going to be market sector, it's segmentation, is what we believe.
Sure. And Mark, how does Selectria view the dynamic?
Yeah, I mean, we offer string inverters and central inverters, and it really comes down to the approach of the EPC, the developer that we work with right now. Some of them definitely have preferences for central inverters, and they're looking, forward to 1,500 volt, 2 megawatt blocks for their multi-megawatt projects. And then you got other people who really have quickly adopted string inverters, and we're seeing projects up to 10 megawatts with string inverters as well. I think those two solutions will coexist, for some time. Mm-hmm. I can't predict what it'll look like 10 years from now, but at least in the near term, there are definitely, two paths for those larger projects using a centralized or a decentralized approach.
Yeah, yes. and so in terms of, what are some of the levers that the EPC is thinking about when they're considering the string versus the central then? Why are certain EPCs, especially in these larger projects, moving towards that decentralized solution?
Yes, I think definitely, first thing they're looking at is uptime, right? Uptime. So actually, right now we're in construction of 2 string inverter projects, one in Georgia, one in New Jersey. They are all 6 and 8 megawatts level. So the experience we got from the end user or the EPC company that is, often you have the string inverter, let's say worst case scenario has got failed. Before they can get on the phone to give you a call, they already got a technician to replace one of the spare units on site. So this is real value that a string inverter can provide, is to really minimize your downtime. Consider if you have some central inverter that you at least are waiting for about 24 hours to get a turnaround to bring one of the central inverter back to the line. I think that's really a concern for the customer, that how you can really looking to the service structure can guarantee in the next 20 years, you will still get same type of performance as we have right now.
Yeah, I kind of agree with that, and I'd like to put a layer on the business structure. So you mentioned, what makes the EPC consider a string versus a central? I think it's, do they own the O&M? So, does the EPC just do the installation, or is there a service component of it? And if there's a service component of it, then that uptime and that availability becomes a bigger factor of it.
David, I'm curious to hear why.
Yeah, I have to agree with that. I mean, the service costs and your risk avoidance on availability are the main drivers. So there's some other tertiary drivers such as landscaping costs and proximity to service centers, but it's all about avoiding that long-term service cost. And when you go the distributed approach, you then become very agnostic in your plant. There's no reason why I can't start switching out SunGrow with the Keiko or vice versa if I'm doing a distributed architecture like that. So you hedge in some real variances that protect your investment over life. It's a lot harder to swap out a central inverter than it is a string inverter.
Mm-hmm. I'm curious then, we're talking about decentralized solutions and then pushing a level beyond that, beyond just the string level. I know Keiko just released the ultraverter. Mike, of course, SolarEdge looks at DC-DC optimization. I'm curious, but from SunGrow and Selectra's perspective, how do you guys look at going beyond the string level for distributed optimization and leveraging some of those similar benefits of that string inverters brought?
Right. For this year, we have 56 kilowatts inverter that's offer full MPPT. So, because right now we're not in the residential market, so we're not on the panel electronic side. But again, from the string inverter perspective, we think providing enough MPPT tracking and provide a more intelligent string level monitoring would really help the customer to diagnose the plant. We had experiences in Georgia that our monitoring system helped the customer diagnose the string difference when they do the connection on-site installation. So there's a lot of new features in that inverter can help the customer and users to monitoring site, managing the assets more smartly. I think that's another way that we can consider new features into the inverter that will help on the string level to diagnose and long-term operations.
Sure, so bringing that optimization, but still keeping it within the string inverter architecture.
Yeah, I mean, our philosophy is similar. We're looking to really just continue to innovate on the basic string inverter and central inverter architecture and put more intelligence into the inverters, as well as the combiner boxes as well to handle special requirements.
Mm-hmm. Sure.
So, well, one of the things that we've noticed, I guess comparing it to going on site with an IV sweeper and trying to diagnose something at the string level, is there's a lot of tribal knowledge that goes into that, to the point where they're writing articles on how to do it and what these curves mean. What we're seeing on the optimizers is you have enough granularity that you can make a computer or an algorithm do it. So, for example, if a diode goes out or if you have a hot spot, you're looking at a voltage shift in the voltage MPP. We're tracking that out of the module. And I can create a diagnostics algorithm that will run almost an IV sweep throughout your entire plant every day if I want, and that's hands-off for the installer. We're seeing guys who do their own O&M, negotiate out site visits in some cases where they can submit this report. It's in a lot of ways better than an on-site IV sweep, and they can do an automated diode check for the entire array with a push of a button. You can check for soiling, you can check for broken modules. And that's all from an operations cell. So that's if you take it to the module level, there are other benefits that come out, and that's been our experience with it.
Sure.
Yeah.
David?
Yeah, I want to touch on that too. I want to make another analogy to the automobile industry. Today's automobiles are more fuel efficient, they're lighter, the cost has pretty much stayed flat, right? And they have 4 core functionalities, and I think inverters have 4 core functionalities as well. They condition the DC, they invert it into AC, they manage the grid, and they've got COM. Where you choose to co-locate those gives you advantages for O&M diagnostics and extra yield, right? In SolarEdge cases, they've taken the DC conversion and they're sticking it on the roof, right? String inverter has everything as close to the point of common coupling as possible. And with the ultraverter, we're doing the conditioning and the inversion at low voltage on the roof, management and COM on the wall. So I think by moving these pieces around, you can get very much like the automobile industry. You've decided to invest more technology in fuel injection and variable timing. The automobile is the same. But by taking some technology and moving it around in the core functionalities, you find out better cost points and better energy yield and better services you can offer. So I think we're following that path, and I think that path is going to continue.
So what are the trade-offs involved in your architecture, the way that you've architectured?
So we're actually doing a few firsts. And I'm really proud to say that because firsts come across very rarely, right? And so we're doing a low voltage inversion. So I mentioned earlier, the higher content of commodity products you can get in your inverter, the better off you are. By going to low voltage inversion, we access a completely different class of electronics that can't be accessed for a typical high voltage inverter process. So we're coming out at 30, 40 volts of the module, coming out at 40 volts AC and stacking them, an AC stack, much like you would do a DC stack. And this allows us to get some real operational efficiencies and some cost premiums as well on the downside. So we can have one product that runs globally. Right now it's running on 3 continents because it stacks AC. It doesn't care whether it's 50, 60, 270, 230, 690, right? It's stacking the AC. So this is some of the unique aspects of this technology. We're going to introduce several primary firsts and a couple tertiary firsts as well by moving to a low voltage architecture on the AC side.
Mm-hmm. What about you, Mike? What would you see as the trade-offs of putting DC and then still keeping the traditional inverter, central inverter?
So one of the things that is core to our technology is we just kind of took the inverter apart, laid the pieces out on the table, and tried to figure out where they belonged. And the DC to DC and the MPP, that looked like it belonged on the module. And so we've got a rooftop component now. It's a DC to DC converter, just like David's describing. But now we have a treasure chest open in front of us of available technologies we can put into this device. We don't need to bump it up to 240 AC. We can just go from 30 volts DC to 33 volts DC, or maybe it's lower. So from a technical point of view, our challenges are easier. What then you say is, well, don't you have something here and something on the ground? And I think psychologically that's probably our biggest challenge, is just having the components in 2 places. From the cost element of it, we took the string inverter and we took the wide MPP tracking window and we shrunk it down to a single number. It's a fixed voltage inverter. And when you do that, you take a lot of parts and components out. So now we are left with a string inverter that is one of the lowest cost string inverters possible that you can make. And that's where we get a lot of our cost savings. So when you couple that with the power optimizer, we're very close in residential to string. And in commercial, when you tie in the balance of system benefits, there's almost no delta anymore. So we've been able to get through the cost benefit. Now it's just a question of finding a spot on the wall to hang the inverter.
Mm-hmm. I want to get to another topic that Mark brought up, which was some of the new safety requirements around like arc fault combiner or arc fault and rapid shutdown. First of all, are there other safety requirements that affect the power electronics that you see that may come up in the U.S. in the near future?
In what regard?
And just anything that would affect the type of inverter that you would need to purchase, the way that you design the power electronics or the electrical balance of systems.
Well, I mean, rapid shutdown, I don't mean to overstate things, but it's made people choose SolarEdge. So, that's to put it bluntly, but in a lot of ways that's what's happened, is in markets where you have rapid shutdown and it's inactive, SolarEdge has one of the few solutions available, but it's also one of the best cost solutions, and it's what you're already installing. So, I don't mean to overstate it, but it has driven people to choose our product specifically because it's very well positioned for the rapid shutdown solution.
Sure, and before I let one of these gentlemen respond to that, just to make sure everyone's on the same page, rapid shutdown is the new requirement within 2014 NEC?
Yeah, 2014.
Yeah.
Right, 24 NEC, which means that you have to shut off the DC lines within 10 feet of the array. So it requires oftentimes maybe some additional materials or locating the inverter closer to the array and some other factors. But
Yeah, I mean, certainly 2014 code has been driving some inverter decisions, and I think probably in favor of your solution in some cases. But it can be handled, with central inverters, the way it's done is you have, a smart combiner box where you can do the rapid shutdown and the arc fault detection. With 3-phase string inverters, it's actually, built in, the arc fault detection, and then the rapid shutdown has to do with the placement of that inverter, near the building. So, all the solutions out there now, can be adapted to meet these code requirements. It's new, and people are figuring out the best way to do it.
Right, and I think that's people are talking about what the best solution for rapid shutdown. I mean, that really came from the firefighter department, right? So the firefighter want to get into the building, they don't want to get get a dangerous situation. So that's why you want to reduce that DC voltage. I mean, there's lots of, the method can be implemented to compliance with that code. I can't speak of a residential inverter, but for the street inverter, we have arc flash detection inside, and you can easily place the inverter within 10 feet of the edge of the array, and putting at the same tilting angle as the racks as a standard offer to the customer. So there's lots of options that can be chosen to comply with the code.
What about anything in the future? We've heard people talk about potentially doing it from 1 foot of the array, which would necessitate module level power electronics. Will that get any legs? Is that something that you're looking at down the road?
I'd like to have an opportunity to respond to that. So, I mean, when there's more regulatory and safety work going on right now, I think, in the history of the solar industry with the standards and the National Electric Code. And let's be cognizant of the fact, for the first time, the National Electric Code, when it rolls over, people are adopting it immediately. There used to be several year lag, right? That's gone away as the industry has gotten more and more aware, and the firefighters have gotten involved. So when you bring a technology to market, you want to make sure it's forward compliant. Right, and this is part of the value the distributed inverter architecture brings. We don't, if 2017 mandates module level disconnection, okay, we're already there, right? If they start managing on the Rule 21 side advanced grid features, well, we're a full bridge, right? We can go manage the grid, right? We can do 0 to 1, power factor. So when you design your equipment, you got to look a couple years out. You have access to these regulatory committees. Make sure that you're participating in them. Make sure you're casting your vote and you're influencing people, and come out with forward compliant components. And the other part of the forward compliant hardware is the communication. At some point, you're going to have to talk to this device to make it do new functionality. So you have to have extremely robust communication. And this is one of the reasons most of our new products are coming out are focusing on cell back data 100%. Right? We believe that that's a wagon we can ride for 4G for 20 years.
I'm actually curious to dive into that a little bit, because part of, for those of you that were in the session yesterday about advanced grid integration with PV inverters, one of the things that we talked about was right now Rule 21 interconnection, which is bringing some of these advanced grid integration functionality to the distributed solar level. The next phase of that is going to be about communication. And right now, one of the big battles there is, of course, what protocol, as far as communications go, is going to be built in. So how, as an inverter manufacturer, do you plan around that? You got to start doing the R&D on the next generation of inverters, but how do you deal with the fact that there is this cloud over the regulatory process in terms of what's necessary?
I don't see that as difficult, and I'll tell you why I don't see it as difficult. You never want to embed your COM on your main PCB boards, because there's different reliability and different warranties associated with that COM equipment, so you want to associate it as a daughter board, right? And with a daughter board, you can then be a lot more flexible moving forward as they come out with new protocols that you need to do, right? You pull the board off, you put a different board on if you have to, right? So I think that's, from a hardware perspective, that's how you would manage that.
I think there's just a behavioral aspect. Participate, be a part of these conferences, be a part of the meetings and the groups, and just be a part of creating what that infrastructure looks like going forward, so you're not taken by surprise.
Yep.
Yeah, I would agree. I mean, it's critical in the industry right now that we do all get together, and work towards standards. Communication protocols are really important so that we're all talking the same language, because many owners have portfolios of projects using different inverters that ultimately all need to communicate and back to the utilities. And right now, there's no way to do that. We still have a long ways to go to create some communication standards that are just going to really, reduce the cost of developing and operating PV plants.
Sure. So, we have just under 10 minutes left, so I want to make sure that we get some questions from the audience. Does anyone have any questions? So we have one. Let's do this gentleman in the third row here.
Hello. You haven't spoken too much about data in terms of big data. Where do you guys hold on that? And a quick side question, has the SolarMax closing affected you guys in any way?
Oh, so two very different questions. So let's start with the data one first, and I think this is related to communicating with inverters as well. what have do you guys have a collection of data, as far as performance or on your inverters themselves, and what have you been able to do with that?
We probably have one of the largest databases of module performance in the world today because we have shipped over 4 million optimizers. We track a good percentage of those. I think when you handle that much data, you need computers and algorithms to do the work for you. You need colored charts so you can see your array from a bird's eye view. You can see into the electrical performance. You need to have little line graphs and automated alerts that come to your iPhone. So they're just these algorithms that need to be created, and you need to continually innovate based on the data set that you've got to come out with new ways to take advantage of it.
Anything to add? How about instead of just picking on SolarMax, obviously we've seen a significant number of hurt in the inverter industry. Companies, declaring insolvency, going out of business. Some of the publicly traded companies taking a big hit as far as their market valuation. How does that affect how you're doing business, and what are sort of the questions that have come up against you?
Well, I can answer that. I mean, I think there's definitely consolidation going on in the inverter industry. We've seen it in the past several years. I've worked for Satcon for a while, and coming out of that when Satcon went bankrupt, and I was at Selectria. A lot of people wanted to work with Selectria, but we're still a little worried because we're a private company, and we're wondering if the same thing would happen to us. So I mean, for us being acquired by Yaskawa, a global $3.6 billion company, 100-year-old company, is satisfied that question and that concern. And I think it's a legitimate concern now as the company gets bigger. You got the industry gets bigger. You have these 25-year assets. You want to make sure that you're going with someone who's going to be around to support that warranty for those 20 years.
Yeah, exactly. I think the bankability and the sustainability is that something that customer always asking about, how you can really maintain you're going to be there for the next 25 years behind your project. That's a very key factor that people would evaluate. So I think the profitability is the key. So we always think that if you can maintain the profitability today, you'll never be profitable tomorrow. So because right now we see the dropping pricing, we see the competition is getting more and more steep. As we can see that moving forward, you're pushing your product into the new technology, keep that leading edge, and also maintain the product, be profitable. I mean, that's a real challenge for everybody in this industry. End of the day, I think that's going to be good for the whole industry, because I believe end of the day we're not competing with each other, we're competing with other resources, such as coal, such as hydro, such as others. As long as we can hit to that parity point, that's the only thing that we can have a thrive future.
Sure, that's it's one way of looking at it, but I'm sure you're still competing on the purchase orders too. Right? Not at all. But Mike, I'm curious. You guys aren't public yet, so if as far as
are you going to write another article now?
Jeez. But as far as obviously you're a private company. You're a relatively newer company. You're not backed by a huge industrial conglomerate balance sheet. How do you assure the sort of bankability and then the fact that you're going to be around to honor these 20, 25-year warranties?
So, mainly we do it the same way anybody else would. It just, obviously, our information isn't public. So, under NDA with large customers or large commercial developers, we're open, and they've had a chance to audit us and validate us, and they feel very comfortable with it. So, it's minor difference that our information is not public, but when it comes to a functional level, they're seeing the same thing.
I'd like to have an opportunity to comment on that as well, because Keiko New Energy is, as far as I know, the largest privately held solar inverter company. And so we have to approach it the exact same way, right? We have financials, we are profitable, we're happy to show them to the right people at the right time under an NDA. And whether you're public or not, it's mandatory at this point in the industry. You have to have the opportunity to be audited by your significant customers.
Sure. I know we had some other questions, so I want to get to them. So right here in the front.
Yeah, hi. My name is Navneet Trivedi, and I have a question to you regarding the, future of inverter technology, if you want to call it. So today, I heard in this discussion, mostly about optimizing the solar power. And I was few years ago helping Whirlpool to design a controller for home because they wanted to manage the home area network. And yesterday we heard a lot of things like storage and electric vehicles and all. So is that kind of, inverter technology exists today which can, act as a controller for the home? If not, is there any vision for that? And I don't know if it exists, then what is the price differential between what inverter we talked and what kind of the inverter which can help manage the home as a one unit?
Sure. What about the inverters addressing either the connected home or the connected commercial building?
So, I mean, Europe's ahead in a lot of ways, especially Germany for that kind of thing. So what we're showing at Intersolar in Europe is just that. We have a solar edge energy management solution. Basically, it takes the PV power that's coming from your rooftop into the inverter, and it dispatches it where it needs to go. So there you're financially motivated to self-consume. So the first place you'll put the power is in the house. If there's already demand, then demand can be adjusted within the house too. You can turn on a boiler. Maybe you have an EV that you can start to charge. If there's no more demand to be had, then you can disposition it to maybe a storage unit, and those are very scalable in design. So I think it's this dispatch capability that you'll start to see coming out first, where now you can control the end destination for the electrons.
Yeah, I don't see that as a difference in inverter technology, and the reason I'll say that is that we've got storage systems for self-consumption in Europe as well, right? And we're using the same inverter bridges. We just stick them in a different enclosure with different levels of intelligence to do just that, right? Tell people to turn on certain appliances at certain times, and couple it with the energy storage, and we sell it as a package. Same inverter technology, just a little additional communications.
Yeah, right? Exactly. I think definitely they're changing market requirement, and one of the good thing about as being a pure player is being a fast responder to the customer requirement as future provision of the energy storage and grid supporting functions. That I think is moving forward is a trend.
Sure, and I think we have time for maybe one last question. Right here in the middle.
I'm Stephen Smith from Solvita Energy Group. I had a question about bankability and performance modeling for inverters. Over the last couple of, probably 4 or 5 years, we've seen increased requirements to validate photovoltaic module files through third-party entities like RATC, Black & Veatch, PVEL, but we haven't really seen that happen yet for inverters. And so I wondered if for any large contracts, you've been asked to have your OND file, which is the file that goes into PVSys, validated by any third-party entities.
I'd say that's currently existing right now. I mean, we just went through that due diligence 2 years ago, maybe not even 2 years ago, on our Central Inverter Platinum for the 400 megawatt 6-year contract with CPS. And we're going through the same analysis with our Ultraverter. We've got contracts with PV Evolution Labs, got contracts with Kima to do just that. So I think it's common already. It's accepted practice, at least from my perspective it is, because I've been doing it for a number of years now. I view it as mandatory.
Yeah, I agree with that. We've seen that recently in the last year or so too. And up to this point, we really haven't had to deliver that type of information, with many customers. But I think, again, industry is getting bigger portfolios, more finance folks in the background. And so I think these third-party studies are getting more important to the inverter space as well.
Yeah, they're not free, by the way.
They're not. Yeah, apparently we see the trend, right? The industry is getting more mature, and those requirements are coming up. And also we have come across a few scenarios that customer require for third-party verified OD file and how we can evaluate your inverter performance. And yeah, I think the infrastructure is building up right now just to accompany those needs.
Sure.
There's more solutions than PVSys coming out. Folsom Labs has their own.
Yeah.
Enroll has done a number of shade studies.
Right.
So you're evaluating multiple MPP zones now. That seems to be the trend.
Right.
You do a large MPP zone, a string MPP zone, a module or bi-module MPP zone. So the algorithms are changing as we speak too.
And let's not forget, we're in California, and there's something called the CEC, and they have an efficiency test, right? That's third party, right? Multiple voltages, 5 different power set points. I mean, that's oftentimes in confliction with the O&D files you'll find in PVSys.
It's true.
So I think it's current practice already.
Sure, and that's unfortunately all the time that we have for this session. Next up, we have lunch, and which is always everyone's favorite session too. But in the meantime, please give our panelists a round of applause.
Thank you, Jay.